Welcome back to the explainer. So, over our last couple of sessions, we spent a lot of time focusing on generating these really beautiful professional documentation sites for Python projects using tools like Sphinx and mdocs. But today we're shifting gears. We're transitioning from just documenting our code to actually packaging it. We're going to be diving deep into Setuptools, which is the foundational tool designed for packaging your Python projects so that anyone else can just seamlessly install them. By the end of this explainer, you're going to have a really solid behind-the-scenes understanding of exactly how the whole Python ecosystem distributes code. Now, we already established earlier in our series that pip downloads a package directly from pypy, the Python package index, and then installs it straight into your environment. But think about this for a second. How does that package's original author actually get it published up there in the very first place? I mean, code doesn't just magically format itself and upload to the internet, right? There's a very specific underlying engine that's genuinely driving that entire process. And to answer that, here is our roadmap for today. We're going to cover under the pip install hood, the evolution of packaging configuration, wheels and package discovery, creating command line tools, setup tools versus poetry, and finally, packaging best practices. Okay, let's jump right into Section 1, under the pip install hood. So while pip is an absolutely fantastic tool, it essentially just acts as the delivery mechanism, right? It just pulls from pypy. Setup.tools, on the other hand, is the specific dedicated tool that genuinely makes the entire process of packaging your own code possible. It takes your raw source code, structures it, and bundles it into a standardized format that the broader ecosystem can actually understand and consume. Without Setup.tools, that seamless one-click pip install experience we all take for granted, it literally wouldn't exist. Moving right along to Section 2, Evolution of Packaging Configuration. There's been a massive shift in the Python landscape recently. Historically, developers defined absolutely everything, project names, version numbers, all their dependencies, in a file called setup.py. You'd literally call a setup function right inside this file and pass in all your metadata. It was the core of the Setuptools system for years. But the ecosystem has since shifted to a considerably more modern approach, and that is pyproject.toml. See, before this transition, different Python tools each kind of used their own distinct configuration files, which honestly created a bit of a fragmented mess. pyproject.toml totally solves this. It provides one single standardized location for your packaging configuration, no matter which underlying tool you're using. And modern Setuptools has fully embraced this to ensure total reproducibility across all your environments. All right, Section 3, Wheels and Package Discovery. You've probably heard the term wheel thrown around before. A wheel is basically a genuinely pre-built package format. It's specifically designed to make your installations blazingly fast because it packages up everything necessary in advance. And Setuptools is the exact tool responsible for building these wheel files right out of your source code. Because of Setuptools, when a user downloads your wheel, they don't have to compile a single thing themselves. Pip just drops those pre-built files right into their environment. It's a total game changer. But here's a good question. How does Setuptools actually know which specific files and folders even belong in that wheel? Well, it uses a remarkably practical capability called package discovery. Setuptools provides this really handy find packages function that automatically scans your project directory. What it's looking for specifically are folders containing an __init__.py file. When it spots one, boom, it identifies that folder as an installable package. This is absolutely huge because it cuts out so much tedious manual configuration you'd otherwise have to do if you were listing every single package by hand. Up next, Section 4, Creating Command Line Tools. Now, this brilliantly connects back to the command line tools like Click and Typer that we thoroughly covered together in episodes 58 and 59. Setuptools has this incredibly powerful feature called entry points. By defining entry points in your pyproject.toml file, Setuptools will actually automatically create a standalone command line tool upon installation. The flow is super simple. First, you define the entry point. Second, you connect a custom command name directly to the click or typer function you wrote. And third, once the package is installed, the user simply types that command name straight into their terminal. They don't have to run python script.py, and honestly, they don't even need to understand how Python is working underneath. Setuptools handles the whole routing process automatically. Which brings us to Section 5, Setuptools versus Poetry. So we covered poetry quite extensively back in episode 3, and it's actually very similar to the relationship between Psycho P2 and SQLchemy from our database explainers.
Setuptools basically represents the lower-level foundation. It's the standard library tool that gives you immense, fine-grained control over the packaging process. Poetry, on the other hand, provides a considerably more streamlined, all-in-one experience. It handles your dependencies, virtual environments, and packaging all under one roof. But, and this is the absolute crucial takeaway here, Poetry actually relies on the underlying packaging standards that Setuptools helped establish in the first place. They aren't competing in completely separate worlds. Poetry is literally built upon the foundational concepts of Setuptools.
And finally, Section 6, Packaging Best Practices.
So picture this. Your team at Uplatz just built a brilliant custom data validation library. It works flawlessly on your machine, but now you actually need to share it so separate teams can install it using pip. Following these best practices gives you the tools to share it securely and properly. First off, absolutely use pyproject.toml for all new projects going forward. The setup.py approach is historical. It's time to embrace the modern standard. Second, really take full advantage of entry points. Whenever your package includes a command line tool, it just creates a wildly better user experience. And third, remember that both Setuptools and Poetry are solving the exact same underlying problem. Just choose your tool based on your project's specific need. Do you need foundational, low-level control, or do you want that all-in-one convenience?
Okay, so you've configured your pyproject.toml, Setuptools has successfully discovered your packages, and you've built a perfectly distributable wheel. Your package is completely built. But how do you security share it with the world? Once that code is packaged up, you still need a secure, reliable way to physically upload it to pypy so other folks can actually run that pip install command we talked about. Which leaves us with a pretty provocative final question. Exactly how secure is that bridge between your local build environment and the global Python ecosystem? Well, that is precisely the subject of our next explainer covering Twine. If this explainer helped demystify some of the magic happening underneath your terminal today, definitely stick around because we have so many more incredible tools to unpack. Thanks so much for watching, and we'll see you in the next one.